You're going to need to know how to evaluate limits algebraically. Okay, so that will be, you won't have a graph in front of you. And using your calculator, it may not be exactly obvious what to do. So the first thing that we're going to do is we're going to kind of categorize these. You need to know that the limit of any constant function is simply that constant. So if you look at 4a and 4b, these are both constant functions. It doesn't matter what's in here. Does not matter. The answer, the limit as x goes to absolutely anything, is just that number. So the first one is 4 pi. The second one is 16. So we'll just make a note out here that a and b were constant functions. Okay, on the next ones, you want to use substitution if at all possible. And although there won't be a lot of these on the quiz, substitution is what you should always try. You just don't use substitution if it makes the denominator equal 0. But in the next three examples, the denominator doesn't equal 0. So the only challenge to these next few problems is just understanding some basic pre-cal terminology. So x to the 1/2, that means the square root of, or the root of x to the first power, the second root. Okay, so what we're looking for, the second root is really just a square root, so we don't need to write that. And x, we now substitute it in, is 4, so the answer to this guy is 2. Here, if we plug 5 into our denominator, we're just fine. Okay, so I can plug it into my numerator as well. Okay, so it becomes the 5th root of 32 over 2 to the 5th, which is 32. The 5th root of 32 is 2, so it's 2 over 32. And if I reduce, it's 1/16. The last one, you need to know your unit circle. Okay, that's going to be important to you. Pi over 4 is right here. It's at 45 degrees. You may recall that it's root 2 over 2, root 2 over 2. So if we're thinking of the tangent function, the tangent of pi over 4 is simply sine of 45 degrees over cosine of 45 degrees. Root 2 over 2 divided by root 2 over 2. No fancy arithmetic there because anything over itself is just 1. The next thing that you have to know how to do is you need to be able to factor effectively. So I've put some examples on here of things that we can factor. And I just moved the screen up a little bit here. But on the first one, let's see, x squared minus 6 plus 8. If you plug 4 into that denominator, you'd get 0. So we're going to use the strategy of factoring and canceling. Okay, so this becomes 4 minus x on the top. On the bottom, that becomes x minus 4 times x minus 2. And I can cancel. Those two cancel. But remember, if you've got any two numbers where you're using subtraction and all you're doing is you're switching the order from the top to the bottom, when those two guys cancel, they cancel as -1. So you want to make sure that that's part of your answer. So now we can rewrite this as the limit as x goes to 4 of -1 over x minus 2. I can now plug 4 in. I get -1 over 4 minus 2, which is -1 over 2. So my answer is -1/2. Okay, on my next one, right here, if I plug 3 into my denominator, I have a problem. So again, I'm going to factor this and see if I can cancel stuff. And what I have there is the difference of two cubes. So I'm going to copy, square, square, opposite product in the middle. There's my 3 minus x. So if I take the cubed root of x cubed, I'm left with x. If I take the cubed root, -27, it's -3. So copy the x, copy the -3, square the x, square the -3, you get +9. And if their product of these two things is -3x, the opposite product is +3x. Now I can cancel. And again, I've got that same weird situation where the top is the same as the bottom, except the numbers are switched. So I've got to remember that that's a -1. So my answer now is we're taking the limit as x goes to 3 of -1 times that stuff, x squared plus 3x plus 9. I now substitute 3 in for both the x's, and I get the opposite of 9 plus 9 plus 9. So my answer is -27. On the next one, if I plug 4 into my denominator, I have a problem. So I'm going to again try to factor. So I know if I were factoring this out, I've got 2x and x. Now, even if you are challenged with factoring, okay, a big hint is to look at your denominator, okay? See if you could put that same factor in your numerator and make the factoring work. And in fact, you can. When you do it, you see that if you go put a -5 there, it works. Those cancel out. So you're left with the limit as x goes to 4 of 2x minus 5. You just substitute in there, so you're going to get 8 minus 5. So the answer is 3. On this last one, don't get scared off by the fact that you've got x to the 4th. If this problem were x squared minus 26x minus 25, that should be a plus 25. Okay, if that were x squared minus 26x plus 25, you could easily factor it into x minus 25, x minus 1. Okay, but it's not. We've got x to the 4th. So if this is a 4th and that's squared, all we're going to do is put a squared in there, a squared in there, and now that's properly factored all over x minus 5. We can see here, well, in both cases, actually, we've got difference of 2 squares, but I don't really need to worry about the second one, but I'll go ahead and factor that. X plus 5, x minus 5, x plus 1, x minus 1, all over x minus 5. Ah, great satisfaction. I can do some canceling here. Let's see, got to get my pen going. Great. So now I can go back in, do my substitution. So if I plug 5 in for all of my x's, I'm going to end up with 10 for my first term, times 6 for my second one, times 4 for my third one. So my answer is 240. And we are